Okay, so I'm doing this right fastly because we don't have a ton of time and there's no time. Okay, so let's talk about the general first, and then we'll go on to a more complex example, right? So we got two different types of circuits we've been talking about. We talk about those series, we talk about the parallel. The easiest way to tell the difference is by looking at them, but the other easy way to remember is that series, when it comes out of the battery, it comes down, and then it follows a straight line through each of the resistors, and then it makes its way back to the battery. For parallel, it is different significantly. It takes its time out of the battery, and then at this junction right here in our drawing, it splits into three different places. So part of the current will go this way, part of the current goes this way, and then part of the current goes this way. And then these three currents will come back together on the other side. Okay? Right there, those three. So in parallel, there's always a split of some sort. There's always a branch. There's always something along those lines. So why don't we solve these two using the equations that we learned, and we will see what the total resistance is for each. So the series circuit right here, we got 10 ohms, 20 ohms, and 40 ohms. So if you recall, the total resistance of a series circuit looks like this. It's the first one plus the second one plus however many there are in the circuit. There could be 4, there could be 5, there could be 20. In this case, there's 3, so we go R total equals 10 ohms plus 20 ohms plus 40 ohms. And then we plug that into our calculator. And we find that we get 70 ohms. Alrighty. Now, over to parallel. Parallel, once again, is the brancher. It branches and branches and branches. In this particular case, it has 3 branches, but the general formula looks like this. 1 over R total equals 1 over the first resistor plus 1 over the second resistor plus 1 over the third plus 1 over the fourth plus 1 over the fifth, however many you have. In this case, we got 3. Now, this one will be a little bit different, I suppose. I won't be able to just assume I know everything. So 1 over 10, okay, ohms, plus 1 over 20 ohms, plus 1 over 40 ohms. Now, there are 2 ways to do this. One is by finding the decimals for each of these, and then the other one is by doing least common denominator. In this particular case, we could do either, but I like least common denominator myself. The 3 that we have here can all reach the number 40, so I'm going to multiply this first one by 4 over 4, and I'm going to multiply this second one by 2 over 2. That will leave me with 1 over R tot equals 4 over 40 plus 2 over 40 plus 1 over 40. And if you do that, okay, you find that all of these guys together are total, 1 over R total equals 7 over 40. Now, as you guys know, this is not the end of the problem. That's not how it works. So we have to do the old reciprocal, okay? So we flip the top and the bottom of both sides. Okay, so this will be R tot. I ran out of space. Imagine that equals, sorry, there should be an ohm right there. And there should be ohms all over the place. Oh, all these ohms. Okay, then we should find it should be 40 ohms over 7, 40 over 7 ohms. Okay, now this time I actually will use my calculator. 40 over 7 gives us, that's not right, 40 over 7 gives us 5.714. Okay. So R total in this particular case equals 5.7 is fine, ohms. Alrighty? Now, in this problem, we see that once again, I told you guys this in class, but I told you that this little guy right here always has to be smaller than the least resistor. Okay? And that seems to be the case here. We've got 5.71. The smallest of the resistors here is 10 ohms. So that's good. That's usually a good sign we did something correct. Okay? Now, we go on to something slightly more complex. I have not redrawn these because I didn't want to do them just yet. Okay? So why don't we just go ahead and make one up real quick. All right? So why don't we do one that has a parallel, and then there's a series on that parallel on one side. And then there is another parallel inside of the parallel. Okay? Sure? That's fine. Let's do it like that. So, what we do here, guys, is this is a complex, a slightly more complex version, okay? So what we got to do then is we have to find a way to get all these dudes together, or find a way to simplify it. Okay, so what we can do here is we can do the most complex part first and then work our way down from there. And we can redraw if we need to. So let's go ahead and give all these values a value of 10 ohms for the sake of ease of calculation. Okay, we've done 100 in class, we've done 40 in class, etc. So let's do these two first. Those two are in parallel. We're going to focus on this section right here first. Okay? Oh, shoot. It's okay. This is 10. This is 10. We remember that for parallel, we do 1 over R total equals 1 over 10 plus 1 over 10. That is 2/10. 1 over R total equals 2 over 10. Do the reciprocal of both sides. R tot equals 5. Okay, so what we can do with this circuit then is we can redraw this segment right here to be 5 ohms. We know that that is the case. So why don't we do that? So here we go. We're going to redraw. And this side over here, we can redraw as one resistor because it acts like one 5 ohm resistor. Okay, we complete the circuit. Now, on this part, we see we've got two 10 ohm resistors, and if you look at them by themselves, it looks like they're in series. So there's one, there's the second one. These two guys together, if you recall from the previous examples, we'll just add together. So this is going to be R total for these two equals 10 ohms plus 10 ohms. So total resistance for that side is equal to 20 ohms, okay? So 20 ohms for this segment right here. That's 20 ohms. Now we can redraw this one more time then. Do it on the back. Line, hoi, hu, ha, he, hu, this one is 20 ohms, this one is 5 ohms. Right, that just looks like a parallel. So we do the parallel, 1 over R total equals 1 over R1. You can tell that I'm starting to get a little flustered because of time. Oh boy. So 1 over R total equals 1 over 20 plus 1 over 5. Now, to get these to the same denominator, we have to get this 5 up to 20. Okay, whoa, that's not how you do it. You do it multiplied by 4 over 4. I'm going to redraw this entirely. 1 over 20 plus 1 over 5, multiply it by 4 over 4. Alrighty, this ends up being 1 over R tot equals 1 over 20 plus 4 over 20. Put those together, you got 1 over R total equals 5 over 20. Oh wait, I'm almost out of frame, my bad. 5 over 20. Do the old flipperino. R total, therefore, equals 20 divided by 5. Bing, 4 ohms. All right? So the total resistance of the entire circuit, if we were to redraw it one final time, it would have a total resistance of 4 ohms. And that's how you do it, my babies.